5.5 double angle. So some more identities to throw at you. Double angle identities. So we have 3 cosine double angle identities, 1 sine double angle identity, and 1 tangent double angle identity. And you use them as if we used any other identity. You use them for, like, so if you wanted to pick one of them, you would need to make sure you have everything for it. So if I have cosine and sine, I'm obviously going to use the top one, right? If I have sine only, I'll use the right one. If I only have cosine, I'll use the bottom one, and so on. Alright, so example 1, we're going to find function values of 2 theta given information about theta. So we're given cosine theta equals 3 over 5, and with that, sine theta is less than 0. So we need to make sure that when we find sine theta, that it's actually less than 0. We want to find sine 2 theta, cosine 2 theta, and tangent 2 theta. So first thing I'm going to do is find sine 2 theta. And if we want to find sine 2 theta, first we need to find sine, because we don't have sine. So if we don't have sine, how can we find sine 2 theta? So in order to find sine, well, let's see what we're given. Oh, we're given cosine. If we're given cosine and we need to find sine, you know what we need to do. We do our cosine squared theta plus sine squared theta equals 1. Right, that's like the go-to identity. Most things come from this identity. Let's plug in what we have for cosine. We know cosine, it's 3 over 5. So we have 3 over 5 squared plus sine squared theta equals 1. We're going to square it. We get 9 over 25 plus sine squared theta equals 1. Subtract it over, so we have sine squared theta equals 25 over 25 minus 9 over 25. Keep simplifying, so we're left with 16 over 25. We take the square root, and when we take the square root, we get sine theta equals 4 over 5, but since it states that it's minus, because it's less than 0, we need to take the negative of sine, because it's telling us sine is less than 0. That means sine has to be negative. So now that we have sine, we can actually find sine 2 theta. I need to give myself so much more space. My gosh. Alright, so now that we have sine, we can find sine 2 theta. The reason why we had to find sine to begin with, because in order to find sine 2 theta, we're going to be using the formula sine 2a equals 2 sine a cosine a. So in order to find sine 2 theta, we need sine and we need cosine. So to find our sine 2 theta, we're going to be using the formula 2 sine theta cosine theta. So let's plug in what we know. We have 2 sine, which is negative 4 over 5. We have our cosine, which we already used, which is 3/5. Plug this into your calculator, and we will get sine 2 theta equals negative 24 over 25. Because 4 times 3 is 12, and negative 12 times 2 is negative 24. 5 times 5 is 25. Alright, awesome. We have our sine 2 theta. Now, we need to go ahead and move on to find our cosine 2 theta. So in order to use, to find cosine 2 theta, let's figure out what we actually already have. So we're given that cosine theta equals 3/5. And we're also given, well, we were given it, but we found sine. And we have sine theta equals negative 4 over 5. So those are the 2 values that we know. We're trying to find cosine 2 theta. So we can actually use any cosine 2 theta identity. We could use any of them because we have cosine and we have sine. And if you look at all the identities, we have all the information for that for cosine 2 theta. So the one that I decided to use to find cosine 2 theta is 1 minus 2 sine squared theta. honestly, I don't know why, I just wanted to use that one. You could use any cosine 2 theta identity. Let's plug in what we have. We have 1 minus 2 times sine squared theta. And we know our sine, it's negative 4/5. So what we're left with is 1 minus, so it turns into positive because negative and negative. So 4/5 squared is 16 over 25. And 16 over 25 times 2 is, sorry, it stays negative because we square it. 32 over 25. Sorry, it stays negative because we square the negative 4/5, and then we have positive 16 over 25 times negative 2. We subtract, so 25 over 25, which is 1, minus 32 over 25, and we get negative 7 over 25. And that is cosine 2 theta. And again, you could have used any cosine 2 theta identity. So any cosine 2 theta identity works in this example. So we could have used any of the 3 cosine 2 thetas. All right, now, last but not least, we have to find tangent 2 theta. Now, we could use the identity. We could, but there's something else we know about tangent. We know that tangent is the same thing as sine over cosine. So if we're talking about 2 theta, so tangent 2 theta is the same thing as sine 2 theta over cosine 2 theta. And we actually have those values. We have sine 2 theta and cosine 2 theta, so we're actually going to plug them in. So we have sine 2 theta, which was our negative 24 over 25. We found our cosine 2 theta, which was negative 7 over 25. We simplify our fractions. So we get our tangent 2 theta equals positive 24 over 7. Anytime you're trying to find tangent, if you're given sine and cosine and you have those values, just use them for tangent. Alright, example 2. Finding function values of theta given information about 2 theta. So find the values of the 6 trigonometric functions of theta if cosine 2 theta equals 4/5 and it's between 90 degrees and 180. So first things first, we know that this is quadrant 2. So we're working in quadrant 2 right now. We're given cosine 2 theta is 4/5. So we're actually not given cosine, we're given cosine 2 theta. But we can work backwards because we could use any of these identities to figure out a value. Well, we can't have 2 missing values, so we can only use one of them. We can only use one that has 1 missing value. So you see how this only has 1 missing value, and then this one only has 1 missing value. So we can only use these 2. For me, I used the identity cosine 2 theta equals 1 minus 2 sine squared theta. So I know what cosine 2 theta is. It's 4/5. And that equals 1 minus 2 sine squared theta. Now all we need to do is solve for sine. Alright, let's solve for sine. So to solve for sine, we're going to subtract 1 to both sides. So remember, 1 is 5 over 5. So we have negative 5 over 5 plus 4 over 5, and we're left with negative 1 over 5. And that equals 2 sine squared theta. Sorry, negative 2. Now we need to divide by negative 2. And we divide by negative 2, we're left with positive 1 over 10 equals sine squared theta. Again, I need more space. Don't worry, I before I make another video, I will give myself way more space and prepare for that. Oop. That doesn't go there. Give me a second. I'm not editing these videos either, so we'll just learn to deal with it. Alright, there we go. So we square root both sides. So now we are left with 1, wrong color, my bad. 1 over square root of 10 equals sine theta. Of course, that's positive, negative. And we're going to simplify this. So we have square root of 10 over 10 equals sine theta. Now, we need to know if it's positive or negative. It's positive because quadrant 2. Remember, sine in quadrant 2 is always positive. So that's why we say it's positive. Just as a random fact, it's not random, it's very important. I don't know why I said that. Original sine is 1 over square root of 10. So if we were to use our sine, we use our original version. We use the irrational version because it just makes things easier when we go along. So use the version before you rationalize the denominator. Alright, now we have sine, but we need to find the other ones. We need to find the rest of them. Well, we also have, we just have sine. So we need to find cosine, tangent, cosecant, secant, and cotangent. Now, we can use identities, or we can do a triangle. Since it's been a while since we've talked about actual right triangles, we've been just talking about identities. So when we actually get to the next chapter, in chapter 7, we go back to triangles. So I'm actually going to solve this using triangles. You can use identities, but I'm going to use a triangle. So I'm going to draw quadrant 2. And in quadrant 2, we have our triangle. And we have one value. We have sine, which is 1 over square root of 10. So remember, sine is opposite over hypotenuse. So opposite is 1. Hypotenuse is square root of 10. Now we need to find this missing side. We need to find this leg. So to find the leg, we use the Pythagorean Theorem. So we have 1 squared plus b squared equals square root of 10 squared. So we have 1 plus b squared equals 10. B squared equals 9. We square root it to get 3. The reason why it's negative 3 is because it's in quadrant 2. So now that we have our triangle, we can go ahead and identify the rest of the trigonometric functions. So we have sine theta. We found it. It's square root of 10 over 10. Your final answer should always be rationalized. But if you're working with sine, use the not simplified version. Now we need to find cosine. So cosine theta, remember that's the so adjacent over hypotenuse. So adjacent is negative 3, hypotenuse is square root of 10. We need to rationalize, so negative 3 square root of 10 over 10. Now we need to find tangent theta. So remember that's TOA, so opposite is 1, adjacent is negative 3. You can put the negative wherever you want. Now we need to find cosecant. So remember, cosecant is the reciprocal of sine. So if we're talking about sine, the original sine was 1 over square root of 10. So we just flip it. So we have square root of 10 over 1, which is just square root of 10. Now we have our secant. So remember, secant is the reciprocal of cosine. So we're just going to flip cosine. So, my bad. When we flip cosine, we have square root of 10 over negative 3. And then we have last our cotangent. So remember, cotangent is the reciprocal of tangent. So we have negative 3 over 1 which is just -3. You could have used identities to figure all this out, but honestly, that would have taken a lot longer and it's a lot more work. So sometimes it's easier just to draw a triangle, fill out everything, and then you'll be able to get your information from that. All right, example 3. So in example 3, we want to simplify. In part A, we're given cosine squared 7x minus sine squared 7x. And I don't know if you noticed, but we actually are given the other side of the identity now. So this entire time, we work with the left side. But now we're actually given the right side of an identity. So we just need to match it with one of our identities. And it does. It matches with cosine 2a equals cosine squared a minus sine squared a. So you see how it actually matches? We're given this side right here, the right side. And in this case, our a equals 7x. So if we're given one side of the equation, we need the left side of the equation. So we're just going to plug it in to the left side. We have cosine 2 times a, which is 7x. We simplify to get cosine 14x. That's it. All right, part B. So we're basically going to be doing something very similar. But if we look at part B, we have sine times cosine. So let's look at our identities. Anywhere in our identities, do we have sine times cosine? We do. But do you notice something about it? That 2. We don't have the 2 here. See? There's no 2. Alright, we have no double angle. It almost matches 2a equals 2 sine a cosine a. If we think about it, the only way to get rid of the 2 would be to have multiplied it by 1/2, because 1/2 times 2 is 1. So it kind of makes it go away. That means somewhere in here, when we got to the solution, we're trying to work backwards, that 2 went away by multiplying by 1/2. So we're actually going to add it, we're going to apply it to our function, and we're allowed to because 1/2 times 2 is 1. So we're actually not changing the value of our function, we're just putting something there that makes it work for us. So I'm going to add, or put 1/2 times 2 all times our function of sine 15 degrees cosine 15 degrees. I'm going to distribute that only the 2 out because we need that double angle. So we have 1/2 times 2 sine 15 cosine 15. You see how it's starting to look how we need it to look? And then we use our identity because this is our identity now. So when we have 2 sine a cosine a, it's the same thing as sine 2a. And we know a, that's the 15 degrees. So let's go ahead and plug it in. We have 1/2 sine 2 times a. So 2 times a, which is 15 degrees. Sorry, I want to get that better for us. We're going to keep simplifying. So what we do, we have 1/2 sine 30 degrees. And we know sine 30 equals 1/2. Different color there. So we have 1/2 times 1/2 which is 1/4. More identities. Product to sum identities. So you can read the identities. I'm pretty sure by now you know how to pick and choose and when to use which identity. It's all the information you have. So let's write for cosine 75, sine 25 as the sum or difference of two functions. So let's pretend that 4 is not there. Let's just look at what we're given besides that factor 4. So if we look at it, we have cosine, sine. So if we have cosine, sine, we're going to be using this identity right here. See how it matches? Cosine, sine. And we have two values, A, we have B. So we have cosine A, sine B. That equals 1/2 sine A plus B minus sine A minus B. So let's go ahead and fill out our formula. We'll talk about the 4 in a second. So let's just fill out our formula. We have our A, we have our B. So we have 1/2. My bad. 1/2, my bad. Keep going. Sine A, which is 75 degrees, plus B, which is 25 degrees, minus sine A, which is 75 degrees, minus 25 degrees. Now, what about that 4? What are we going to do with it? Well, you see how it's on the outside of the function? That means we're just going to put it on the outside of our function. We could simplify that right now because we know half of 4 is 2. So we have 2. Let's combine like terms. So we have sine 75 plus 25, which is 100, minus sine 75 minus 25, which is 50. Oh, my bad. Let's go ahead and distribute our 2 to both. So we have 2 sine 100 minus 2 sine 50. And it just asks for a sum or difference of two functions. So you see how we have two functions and there's a difference? That's all. We don't need to keep simplifying. All right, last example. Sum to product identities. So opposite way around. You can read our identities and we use them exactly like any other identity. So let's look at what we have. We have sine 2 theta minus sine 4 theta. And we want to write it as a product of two functions, meaning we want to get rid of that minus somehow. So if we look at the function we're given sine A minus sine B. So let's look for that. Right there. Sine A minus sine B. So that means the identity we're going to use is sine A minus sine B equals 2 cosine A plus B over 2 and times sine A minus B over 2. And that's our A, that's our B. So let's go ahead and plug it in. We have 2 cosine A, which is 2 theta, plus B, which is 4 theta, over 2. And then we have sine A, which is 2 theta, minus B, which is 4 theta, over 2. And from here, let's just simplify as best as we can. So we have 2 cosine, so 2 plus 4 is 6, and 6 divided by 2 is 3 theta, times sine, so we have 2 minus 4 is negative 2, and negative 2 divided by 2 is negative theta. The only thing we need to do is move that negative to the front. So we have negative 2 cosine 3 theta sine theta. Anytime you have a negative inside those parentheses, or the argument is what it's called, we have to move that negative to the front.